good afternoon for everybody in Europe, and good morning or even good evening to some of the people joining us all the way from Asia. My name is Kalina, and I'm very happy to welcome David Raab, the founder of CDP Insitute, which you probably know already, and Thomas Alversberger, our founder of Relay42, in today's session, in which we're going to talk all about AI, machine learning, and how they help marketers when using their CDPs. Welcome, David, and welcome, Thomas. All right, let's get started. So today's agenda is the following. We're going to start with the market development of AI in CDPs. And David here is going to share his insights from his work with many CDP vendors, probably all of them out there in the market. And then Thomas will take the second part, in which he will give more practical examples of how really digital experts are using AI and machine learning in their practice. So he's going to be sharing more of a practical side and a lot of examples. We'll then continue with some takeaways, Q&A, small giveaway, and the whole thing should take around 45 minutes. So without further ado, we wanted to start by asking you guys about what do you know about how marketers are currently using AI in CDP. And for that, we have a little poll, which I'm going to activate in a second. Just give me 1 minute. Yes, you should be able to see it right now on your right-hand side, but I'm going to read the question. So what do you think marketers use AI for? Is it A, to manage huge amounts of data, B, to predict customer behavior, C, to define next best actions and channels and offers, or all of the above? I'm very curious what people think. Let's give it a few seconds. I see already answer A is not popular. B is getting popularity, but a definite winner is answer D. Yeah, I think answer D for sure. 71% said all of the above, and yeah, this is the right answer. And actually, it's probably more, even more on top of what we've already defined in A, B, and C. And this is actually the topic of our session, because we notice there's quite a lot of interest from marketers. There's a lot of ways in which you can use AI in your practice, and today we're going to talk about a few of those. So we're starting with the market development of AI in CDPs. And David, I would like to give you the word. Take it away.
Okay, thank you very much. And we have to adjust the sound here. I hope you can still hear me, right? Very good. All right, so let's talk about market developments of CDPs. And we'll figure out how to advance the slides. So first, some very quick definitions. Artificial intelligence and machine learning are two terms you'll be hearing a lot about. They're not quite the same thing. Artificial intelligence is a very broad topic of machines acting like intelligent people. At least we hope they're intelligent people. Whereas machine learning is specifically about machines solving a problem without being told how. And we'll make a further distinction to note that neither of these things is necessarily fully automated. Often humans are involved in helping the machine learning, for example, to prepare the data for the machine learning system to work, or for that matter, for the artificial intelligence system to work with. So just because something involves machine learning or involves an artificial intelligence, you don't want to assume that it's fully automated. And Tomas will talk a little more about that in his portion of the presentation. So now we'll talk about, well, what's the value? Why would we bother with these things? As the poll so clearly showed, these are used for many different topics. But the value for all those different activities is that they're generally less work, certainly less work for a given amount of output. So you might be able to build a simple rule that would segment your customers into 3 categories, whereas an AI system might segment your customers into dozens of categories that are more precise and therefore result in better targeting and better results. The reason that they give better results is because they can work with more data. They can consider more variables than a rule that you might build manually. They can therefore build more smaller and more refined segments. They can offer greater variety of treatments. They can consider more options and choose the right ones. And they can avoid false assumptions that people make. People have biases, and machines probably, we hope, have fewer biases, although actually bias is a big issue with AI machinery. And they can also adapt more quickly to behavior. If you build a model manually, you have to have some human being do the work, and it can take days or weeks, often sometimes even months, to build a predictive model. Whereas the machine learning systems just watch the data and they can adjust in close to real time to changes in behaviors or to new offers or into new channels or into all other kinds of things. So there are a number of reasons that you get higher value if you can apply AI or machine learning to any given business problem. And this is quite obvious. And these are very, very widely deployed technologies. If you look at the surveys, pretty much every company is at least testing AI and machine learning. Whoops, you go past one. So what are they specifically used for in a CDP context? Two large sort of groups of functions that you might see. The first is in building your customer profiles or assembling the customer data. And AI can help to identify ID types. One of the biggest challenges in building a customer data platform is that there's a lot of work in mapping your source data, understanding what's in the source systems, and putting that into some consistent format that recognizes that this field in this system is an ID, and that field in that system is an ID. And in fact, they're both phone numbers as opposed to one's an email and one's a street address, say. So the AI systems can help with that, can at least guess pretty accurately what kind of data types are available in a given system that they haven't even seen before, which speeds up that process. Similarly, with privacy, they can look at a data source and identify things that look like they might be private personal information or personal identifiers, which are things that have to be managed particularly carefully under privacy regulations. They can help with various aspects of data quality. Again, identifying data that looks like it might be problematic, in some cases even cleaning or correcting the data, applying standardization rules, possibly even making corrections on errors in data that are systematic. So there's lots of applications actually for AI in data quality. Identity resolution, which is matching of people, determining that this email address and that email address are actually the same, which is trivial because they're identical, but also finding out that this email address and that phone number belong to the same person because they were both on the same form, for example, that was filled out. Or looking at fuzzy matching, it says, well, Kalina spelled with a K and Kalina spelled with a C are probably the same person. Somebody just heard it wrong or typed it wrong, which I'm sure happens to you all the time.
It happens in so many other variations.
So, and probabilistic matching is even more complicated. It looks at behavior. So these two devices seem to be used in the same place at the same time. And so they probably belong to the same person. And that sounds trivial, but it's actually very complicated to avoid over or under matching when you use that kind of approach. And then finally, things like text processing, image processing. So reading a text and understanding the entities that are mentioned. This email relates to Relay42 because it mentions Relay42, which again is a trivial one, but it relates to CDPs because Relay42 is a CDP. There's some logic that goes on in there. So you classify that email as related to CDP, and maybe there's a sentiment analysis that they think this email is positive. This says a nice thing about CDPs. And we've never seen an email that said a nasty thing, but there could be an email that said a nasty thing about CDPs, and we classify that as well. So they're all and image processing, looking at an image actually and saying, oh, that's a cat or whatever it is you want to care about. That's relatively rare. There are a few CDP vendors who use this extensively for this kind of work, but it's, I would say, a minority still. But it's a growing field, a lot of value, because this is a very labor-intensive set of activities here. So it's something that is ripe to be used by AI instead. The other use is more on the activation side of things. After your profiles are built, there are a great many functionalities, and this is where, again, those of you who picked one use for AI, tended to predict predictions, because predictions are indeed probably the most common uses of AI and CDP. And there's lots of predictions: next best action, next best offer, next best content, how likely are they to purchase, how likely are they to churn, how likely are they to pay, how likely are they to need customer support, and what kind of support, what's the lifetime value of a new customer going to be. This is a very large set of uses, and probably the most common by far. But there are other uses as well, just doing profiling, understanding segments, building journey maps, identifying opportunities, so finding segments in the data set that have not received a lot of messages recently. Well, maybe they should be getting more messages, or maybe not, because maybe they're unresponsive, and it's good that they don't. But this AI can at least look at that sort of thing. Sometimes it actually can even recommend what kind of message, depending on how smart it is, and even identify unmet customer needs. And there's a special set of applications around advertising, such as brand safety. So looking at the content on a page, which could involve text analysis, could involve image analysis, could involve something else, and say, well, this is on a topic that this particular advertiser doesn't want his advertising to appear next to. Or conversely saying, well, this is a page about cats. Well, I'm a cat lover. I have an ad about cat food. This is a great page to put that cat advertisement on. So I'm understanding consumer intent based on the topics of the content that they are actually consuming, and optimizing campaigns and optimizing media mix. So lots of very specific advertising related applications. And this is much, much more common use. About 2/3 of the CDPs that we have in our data set at least say they do predictive models of some sort. So you'll see AI much more in this. And again, it makes sense. It's a kind of more natural application of AI. Again, machine learning models in particular, that's just what they do, is they build predictive models. So it's a pretty straightforward application, but extremely valuable. Quickly, I don't know why this thing moves so quickly. So, okay, challenges. It's non-trivial to deploy AI or machine learning in a CDP or A+. You need the data. You need to train these systems. And you don't always have the data that you want. It's not always the data that is in perfect shape. So you might have to clean it up a bit. There can be bias. So you might have a data set that only deals with people in the Netherlands. And well, the people in France behave differently. The people in Belgium behave differently. The people in southern Netherlands probably behave differently from the people in northern Netherlands. So you have to look at your data set and understand who's in it, and is that generalizable, or do I have some issues that I need to go out and collect more data or change the weights of my samples? There are ways to deal with bias, but you have to first recognize that bias exists in the data. And sometimes bias is relatively benign, something like geographic distribution. Sometimes it can be more problematic in terms of racial or economic issues. There are issues with understanding what the AI is doing, explainability and governance. So the AI is often a black box. It put in data, a magical answer comes out. The AI doesn't necessarily tell you how it got to its answer. And again, that can be an issue from a regulatory standpoint. The AI may be using data that it's not supposed to be using. Of course, that data shouldn't have been given to it in the first place, but it could sneak in there. It can be correlated. Lots of ways that can happen. So you want to understand what it's doing, or it could be just using some piece of data that snuck in that shouldn't have been there, and it will not be in the future data, but happen to be in the training data set. The classic example being something that is predicting purchases, and the actual purchase history already snuck in there. So, well, guess what? People who bought are going to buy, but you really wouldn't have that data available to you as a variable in the future. So you have to make sure that you exclude it from your training set. Shortages of talent. Again, even though this stuff is automated, it's not fully automated. So you have to have people who can assess those models and look at them and make sure they're doing what they're supposed to be doing and not using data they shouldn't be using. Make sure that they're applied in ways that are appropriate and not inappropriate. Sometimes people take a model and they want to use it for something that it wasn't really trained on. So it'll give you an answer, but it's not really very reliable. You have to know what you're doing to make sure these models are applied appropriately. And that's where that data science talent comes in. And again, there are some regulatory restrictions, particularly GDPR, against algorithmic algorithmic processing, people have to be informed that algorithms are being used. They have to have an option to opt out of use of the algorithms. This isn't things like credit granting and things like that, where people's lives are affected if the algorithm makes a mistake. You have to be careful that the algorithms are clearly identified and are vetted properly. And again, sometimes people have the option under the regulations to simply opt out of being judged by an algorithm. So none of these are insurmountable, but they're all issues that you certainly need to think about when you're deploying AI. So let me now turn this over to Tomas, who will give you more on practical information about how he's been using.
Thank you, David.
Yeah, thank you very much, David. And our behind the scenes support crew figured out your audio problem. It's in your chat, the solution. So digital experts and AI in practice, because there are a lot of possibilities, and David just gave you an overview of what are the sort of most common ones and what are the not so common ones yet to be used. But of course, a lot of AI is for many people still quite theoretical. I think on one of our earlier webinars, we ran a poll, and then a lot of people said, yeah, we're thinking about, but not doing AI. And we are part of a few industry groups on AI, and we're seeing the same kind of thing, where AI is more of a research, or it's a goal, but it's not as day-to-day in practice as we think it should be. And what I wanted to do is take you through a few examples of why that happens and how we think it can be improved. So first of all, if you look at AI, and David illustrated this quite nicely, there is a lot of work involved, right? AI it sounds artificial intelligence, it's machine learning, but the reality is that there's months of quite specialized work by data scientists involved in most machine learning before the machine actually learns the right kind of thing, because you need to give it the right data, you need to structure that data, you need to check in on the examples David just gave, that it doesn't have a bias, it doesn't use data that it shouldn't be using. So there is, it is the machine learning in the end, but you need to be doing a lot of the teaching, and that runs into shortages of data scientists quite quickly in many companies. And even if you have these people, it is quite time consuming. So it takes a lot of effort and just physically, like months of waiting before you get somewhere. Nevertheless, it is worth it to do that, right? We see a lot of big results, and just to give you a little bit of context, I wanted to pick up an actually quite old case study. We did this one a couple of years ago, just to illustrate the impact. We did this together with KLM and with Google. And this model tried to figure out how to optimize a more human approach to advertising. So not blindly target people with ads associated to some click, but really try to more understanding of when should we reach out, what is the right kind of offer for this person, how should we present it. There was all kind of assessment in there to make it more like a human was sitting behind the buttons, while of course it was still an algorithm. And the impact is huge, right? If you can save 40% of your acquisition cost, or get much more acquisition for the same budget, it is worth it to spend a lot of time on that. And this is very much on the acquisition, as David said, that is a very common topic. But similarly, we did a case like this where one of our customers tried to understand, why are people picking up the phone and reaching a call center, and can algorithms figure that out? And turns out, yes, they can. And if you can use that to drive personalization. You can use that to give them solutions before they even reach out to your call center to get to talk to you about the problem, and they need a real human for the solution. So there is a lot of potential in these ways of predicting data and using it. The big tricky part for many organizations is that the process goes something like this, like starting in the top left corner. Basically, someone in a marketing or business team, or all kinds of agile setups, but typically it's the business side that figures out, there is something here that I want to know. Simple example, I want to know the probability of Kalina buying this ticket. Then what I need is a team with typically both a data scientist and someone that has a title like machine learning engineer or ETL transformation data person, basically people that understand how to teach the algorithms, but also understand how to do it, a lot of what we call data wrangling, getting the data in the right formats, making sure that the data you should not have isn't in there, that you don't put too much data in the algorithm. So there's sort of all kinds of plumbing and preparation that can easily take a month or so to get all the people together, get them to set this up. Then the data science team actually gets to work, right? And these guys start to prepare and create a model, and that is very much in sort of experimental way. They play around with it. It's more research kind of work, and that model starts to do some predictions. They run it on some of the data. Typically goes in cycles. They run something comes back, they tweak the parameters a little bit because maybe the wrong thing came back, or it came back but it only worked well on specific training examples, as David mentioned, and not on the generic input that you see. And you could end up from there at a point where you say, well, okay, this doesn't work. The thing we want to predict is not in that data, and you have to go back all the way to the drawing boards to figure out, do we need then other data? So the teams need to work again on what do we feed the algorithm to learn from? Are there different fields or different attributes to give it? Or maybe you're lucky in the first shot, unfortunately that's rare. It works, but then it typically works in a set of data science tools, and these tend not to be production ready kind of algorithms, right? The thinking is there, the math is there, but it's not real time. It's not ready to handle millions or billions of events coming in. It is essentially sort of a prototype or a minimum viable product. And I think as an industry, we underestimated that point. Being part of a few industry groups on AI, we did surveys on data scientists and the teams running these things, and we said, hey, what is your biggest hurdle? Where do you get stuck? It tends to be in that, either in getting that data at the beginning, but if they get this far, it tends to be in making it into production, because then it needs to be handed off to an IT team, it needs to be implemented, needs to be monitored, and it goes out of the hands of that data science team because they're going to work on the next model. So as you see, this process can be quite lengthy. If you add these things together, you'll get to 4, 5, maybe 6 months of work. And both of the case studies I just showed you are around that kind of time, where teams are working on it, are testing it until this is really a day-to-day operationalized thing that is running in production and making the predictions.
And especially if it doesn't work from the first time around, right? If you need to go back to the drawing board and start all over, which is probably a fascinating process.
And that is very common, right? That's almost the normal way, that you try something first, you go back and you try again. That is a little bit the state of where AI is. And even more so, the last part of the journey we've drawn in this diagram, the world also changes. So at some point, you probably need to go back and update that model, because now you're selling, I don't know, different destinations if you're an airline, a different product line if you're a retailer, or it's a new season if you're in fashion, or any of those things mean you probably need to go back and work through this process again.
We saw after 2020 that marketers need to be even more agile and do changes even in a faster pace than they used to. So yeah, the demand changes and the request. So one algorithm that you planned a few months ago might not be relevant for for the winter, let's say, here in the,
exactly. Yeah, and then that length is even more of an issue. Obviously, with this being an industry-wide thing for data science teams, solutions have been designed, right? And moving from this manual approach, a concept called AutoML is going faster and faster, and that is all about having more sort of algorithm-driven algorithm creation. So it's basically computers creating their own models, which means you get a lot more speed and you get to do a lot more choices and trials, because essentially this is an iterative try and learn kind of model where you go back, and we just saw that can be done faster by algorithms. And AutoML is sort of the trend towards doing that. And if you maybe some of you know the concept, but if you look into the most successful examples, there tends to be a lot of AutoML in things like analytics. Both Amazon and Google have tools where part of the BI work is picked up by an AutoML algorithm. They will help you find insights in data, or that will automatically try to do these things. The tricky part about the state of AutoML today is that it's still designed for data science teams. So you still need to do your own sort of data wrangling. You need to still figure out what kind of model do I want it to run, and then it takes some of the iterative works out of your hands. But it is too much a data tool to be used directly by business users in a specific domain. And that is one of the reasons that at Relay we saw that impact, and we said, hey, we want to make sure we get this AI in the hands of marketing teams, and then not just the standard models as we've been doing for a couple of years. We want to have that ability to create new models. That is normally done by data scientists, taking months, or with AutoML still months, but less months. We want to put that in the hands of a business user, creating their own model and have sort of the power to try this without waiting for data science teams. It was a little bit of a crazy idea a couple of years ago when we started working on it internally. We launched it early this year to customers to use. And essentially what we did, we call it Journey AI. So it's an AutoML kind of implementation, but specifically tailored to understanding customer journeys with a few simple goals. We wanted to have the same impact as you would have with the data science team designing these models. So we want the algorithms to do the same kind of work, to create those same kind of use cases. But we want them to do that in a few hours. So do that whole iteration, going back, trying different types of data, different model structures, doing the filtering, etc. To do that automatically, essentially overnight. You're sleeping and the algorithm is doing the work, and the next morning or a couple of hours later, it will come back and tell you, hey, this is what I've come up with. And then because it's computer based, it can do automatic validation and trial runs, and it will tell you, hey, based on the data we have, this algorithm would have an accuracy of 85%, 90%, 95% if you got really lucky, and it will report that back to the user. So there's not a technical skill required as you would have in a data science team where you need to understand how the algorithm got there. It's sort of self-validating and getting itself to those results. With the main purpose being that we want every business user to have algorithms like this in their hands, deploying it, trying it, so we can get to really operationalizing that AI and having it live in a couple of minutes. Well, you can imagine if you plot that out on a similar view, it's essentially still a marketer or a business user that comes up and says, hey, I would like to know how likely Kalina is to buy this ticket from me. But instead, they go in and say, well, I'd like to use a data set. So you get to decide it can use web, CRM, or it can use all data. This is still a decision you have on what you're comfortable with. And you tell it, I have these conversion events happening from other customers in my data set. Have the J algorithm figure out how to predict that kind of event for everyone. Then it takes its magic for a couple of hours to do all of that data science kind of work, right? Data preparation, selecting model types, changing the structure, it adjusts parameters, etc. Goes and trains it, tests it, and figures out on its own, hey, this is wrong, maybe go back. So it goes iteratively. That's why it takes a couple of hours. And then after that, at the end, it will come back with its best shot, right? It will say, I've done hundreds or thousands, it depends a bit, iterations, and I have this as a result, and it will be X% accurate. And it will give you a bit of samples from that. And then as a marketer, you can say, well, if it's that accurate, I feel okay to go and run it. Same for updating it. You just go through the same steps again. And then, and this is where this sounds a bit mundane, right? It sounds like a small step, but we think this is the biggest impact so far we see on our customers. Taking it to production doesn't mean a systems change because it's already in the platform. You basically click a button and say, well, I would like to have this algorithm that I just trained running on that data. And that data is the same as it trained on. So it can itself be live within a couple of minutes, adding things to your customer profiles and helping you run a use case. So far, we have to say it is nearly as accurate as a data scientist. It's within a couple percent. The manual guys are still a little bit better. It's also improving over time. But the real power is that it's there not after a couple of months and then maybe you got it wrong and have to start again, but it's there after a couple of hours. So the cost of any mistakes or trying another one is very low, and you can deploy a lot more of these than you could in the old style of practically trying to run your own manual AI. And then finally, I wanted to give you just a few examples of things we have a lot of customers focus on and try, but I have to say these are examples, right? The purpose of this thing is that anyone can go in with their own question, and we like to be surprised with what customers are doing with it, but these are very common things, right? Understand how likely someone is to buy, what is the next product we think they should buy, what should we show them in terms of products? Are they about to leave us or continue? I think behavioral clustering is quite interesting. It tries, that's the call center example, like it tries to understand when you're going to do a certain action based on previous behavior by others, and similarly, what is the best channel. But over the past months, after starting this on a set of our customer base, we've also learned that our question really typically is, what would be the prediction that really changes your job? What is it that, if you could predict it, makes the biggest impact? So I would almost say, forget about the examples that others did, but have your own thoughts on what you need there, and try this AutoML kind of approach, because you can really just try it and run it and see what it brings you. And I think that brings us to our almost common conclusions on this. I think there is a really big impact to having AI and ML in there. We've just discussed a subset, as David said. The behavioral data is much more common. There are many more of these, and we're hoping that most of you in our audience come up with even more interesting ones. But second bullet, the most common solutions require a lot of time and resources and data science teams, and we think that the future for CDPs really is in taking away that hurdle and making sure you can do this, and you can run it yourself, you can bring it to market, you can learn from it, because bringing it to production has a lot more impact than getting it the last few % more accurate with a longer wait time.
Awesome. Wow, we're just on time. Amazing. There's a lot of information from both sides, both on the market trends and also from Thomas. Thank you both. We are now going into addressing a few of the questions that we got on the chat. Starting with, Ekaterina says, how can we ensure that ML doesn't include bias, especially if it's designed for marketers who would probably not pay too much attention? Oops, yeah, that can happen. We all know marketers, maybe not not all of them are very with the data background. So yeah, the question is, how do we ensure that ML doesn't include bias?
Yeah, even with the ML experts that we speak to often, bias is a tricky thing, right? And maybe in the follow-up we can share, there is a famous case by Randstad, who've done a lot of research on bias, because they're in the selection and recruitment business where this is especially sensitive. The short answer for today's version of Journey ML is it can't do that automatically. You can tell it what kind of attributes not to use. That is a business decision. That's why you select a data set, and you can tell it, well, the algorithm doesn't have access to things like gender or sensitive data sets that you have. But you still need to look at this yourself as well, because there is not at the moment a technical solution that is really capable of avoiding all kinds of bias available.
Right, and they're all improving, right? Especially the ones that incrementally improve themselves. So yeah, they're constantly learning as well. So those biases should also get smaller, hopefully.
Yeah, a lot of checking for bias is looking at the outputs and seeing if they are giving biased results. So are you selecting a lot of males over females, and that can reflect the input data. If you're looking for engineers, well, guess what? There's more male engineers than female engineers, and it looks at first names, and it says, wow, male first names are more common, but you need to control for that and say, you know what, I'm going to, again, adjust my sampling or do whatever I need to do to counteract the fact, even though it's biased, but the bias is reflecting reality. So it is fairly painstaking to look for all those things, and you know, it's easy if it's a protected class, but often it's a little more subtle than that. So imagine ethnic names, which you know, both in Europe and here, you know, someone's name often indicates ethnicity, and that can be a problem. You know, even though it doesn't explicitly state the ethnicity, that the name correlates to that, and if there's a correlation between that and some sort of an output, you have to control for that. So that sort of thing, it's tricky.
Yeah, and this is why there's not a full technical solution yet, right? Data visualization and looking at it works, but the algorithms don't have an understanding of what is and isn't allowed by legal and social norms, because to the algorithm all the data looks the same. So here you do need to look at as a person.
Definitely. All right, and another question. I think Will has two questions. So he asks, how do you handle clients that want to adopt bring your own model approach? Question number one. Maybe this is more for Thomas, because you were talking about, more customer examples.
Yeah, that's
some customers do have their own AI models already in-house.
Yeah, absolutely, but that's the almost the easy part, right? That we've been doing for years. That is really about plugging in those models into existing APIs or loading the data from there. We see more and more that these models tend to live in Microsoft's Azure or Amazon Web Services or Google Cloud. That's sort of the majority of them, and those platforms are very easy to connect to a CDP. So this is almost the easy case that I think any CDP would be, or almost any, I have to say, would be able to do that. What is a little bit more interesting is the other way around. We are still working on, let's say you have the J algorithms design something. How can we then hand it to your data scientists if you want to maybe after running a few of them still do that manual tweaking and get the last few % more? And that is not as easy as it sounds, because the algorithms tend to create things that humans don't fully understand, right? Explainability of AI is a huge research topic. And I think that will get more attention than sort of the easy other way around case where the client already has a model.
Right. And we also have a follow-up question about what functionality we offer to prepare for prepping training data.
Yeah, that's a good one. So that is a big part of what the J algorithms do, and I would almost say that the more research went into how we get the algorithm to select the right data than into having it create models, because model creation is almost a simpler process than data selection, featureization, filtering it. There are a lot of pitfalls in AI if you feed algorithms different data points that aren't actually independent. If they are related, like one is derived from another, that is a risk to some types of models. They don't function if you feed it that kind of data, or they get very wrong results. But that kind of data is very, very common, right? You can have a column on contract start date if you're an insurance or a telecom, and you can have a column with the amount of days remaining. Well, those are very closely related, and it's perfectly fine normally to have that data, but algorithms will trip over. So a big part of the research work for us in the J area is also making it understand that kind of data, making it select features, filtering data, etc. More so even than the final step where it creates the algorithm.
Right. Yeah, complicated process, and I think, David, you also mentioned this being one of the challenges that you also see in the industry. Basically, everybody's struggling with that. Big data, preparing it, making it available for algorithms to do their job, it's probably the biggest part of the job, preparation.
Oh, absolutely. Somebody said that data engineers spend 70% of their time preparing data and 30% of their time complaining about preparing data. So it's pretty much what they do.
Yeah.
Cool. Well, let's take 2 more questions, and then I think we should. I think the discussion is actually quite big on this topic. We probably should do even a follow-up session, but a few more questions, and then we can wrap it up so that we're mindful of everybody's time. So Sarah asks, how do you design the ML models to be separated from the industry or domain-specific knowledge? And she gives a good example, saying that the likelihood to churn in a bank has a different definition from retail or any other sector.
Yeah, this is one reason why we went down this path of instead of what we used to do, offering standard reusable models, which I think many in our industry do. We went down this path of creating tools for users to create new models, because we saw that the reusability of models is limited in a way. It's not as limited as you may think, but we did see issues there, which was one of the reasons we got more sort of bring your own algorithm cases from advanced clients. And that's when we realized, well, we have to make this more bespoke model building approach easier, because us offering standard models is a starting point for clients in an early step with a CDP. They tend to be the same kind of questions, like the example you gave. What is churn risk? What is likelihood to buy? What is next best product? Is nearly everyone wants to do that kind of thing. But the quality gap between a standard algorithm that we would offer to every client across all the industries versus someone in that industry making their own is quite big. And with Jay, we wanted to be very close to making your own, like within a couple % of that, while everyone basically having their own bespoke algorithm.
Yeah. Great. And last question, which actually correlates to one of the questions we got before the webinar. So Elena says it's hard to apply geo algorithms to different platforms. What do you suggest, and which is the best starting point for building applications? And yeah, it's really the big question, right? If you're just starting off or you're thinking about implementing, maybe there's some general rules that marketers should keep in mind before starting.
That's a big one to take as the last question. Yes, it is, and we wouldn't be here with ourselves and the CDP Insitute if we weren't going to say start with getting a CDP, so you have your data in the right place, right? Could have let David say it, but you need to get your data centralized and accessible, preferably in real time, but maybe near real time works for some. And you need to get it structured and cleaned up, because otherwise you're in the wrong starting point. You can buy a race car, but if you're in the desert without a road, you're still not going anywhere. So once you have the data and you have that CDP sort of foundation right, that is where the J algorithms make sense, and where they can start to learn and work on. Even with these more advanced algorithms and with the capability to select and filter training data, you still need to have good data, right? Because it will still select from whatever data you have. So if your data input is a mess, and the examples David gave are very real, where customers are in there under different names, where the data set is not matched very well, then you're basically letting your algorithm learn from something that isn't actually the truth or the real data. So data quality is absolute starting point number one. And then what we see and what we really see develop, and what's exciting for us the most about J and the opportunities it creates, is that you need to sit down and ask that question. Which prediction will really change my job tomorrow? What is it that I then want to know about customers? We still say get a top 5 or top 10 out of those, because not everything is guaranteed to be possible with your data set. And then go and run it, right? Spend a couple of days clicking a few of those algorithms together, run some example campaigns, and learn as in learn yourself, not machine learn, on what works and where the value for you really is.
Yeah.
And I would add, think about the organizational issues. Who is likely in your organization to actually take advantage of these things? What systems do you have in place that could actually use the output? Because you can have a great model score sitting in your CDP, but if your web personalization can't use that output, then it's going to not be any value to you. So there are a lot of other sort of readiness issues that surround the actual deployment of the algorithm itself. But data is by far the most common issue for sure. So I agree with Tomas. That's where you want to start.
Yeah. Get your data in place, and the right people, of course, especially in big organizations with many departments. And AI really has the potential to bring also different departments together, align, and bring value to, not only to marketing, but also to the different divisions within that. All right. Well, before you go, first of all, thanks everyone for joining. Thank you for the great discussion. Thank you, David. Thank you, Thomas. We have a little giveaway for everybody who was with us today. Actually, Thomas and David, they wrote a little ebook on machine learning and its applications for marketers. And keep an eye on your inboxes, as we're going to send it to everyone via email together with the recording of this session. And as always, if you want to continue the discussion, please reach out to us. You can find us on LinkedIn. And of course, reach out to Thomas directly or to David from the CDP Insitute. Thank you everyone for joining. Thanks, Thomas. Thanks, David. And have a great day.